All right, so continuing with problem number 21. Once again, we're just graphing our exponential function and the inverse, which is the logarithmic function, on the same graph. The base in each case is going to be 1 over 7. Oops. So let's graph it. Grab our exponential tool. The base is 1 over 7. And then we're going to grab our logarithmic tool. And once again, the base is 1 over 7. Let's save it. Let's check it. And let's move on. Number 22, it says the graph of a logarithmic function is given. Let's match the graph to its function. So this is kind of similar to the graph matching ones that we did with 6.3, the exponential functions. We have to remember those basic properties of the logarithmic functions and then just apply those transformations. So we can see all of these problems have a base of 3 and it has some type of transformation on the function. So we see that it does still have that that vertical asymptote of x equals 0. So that means the x's haven't been shifted left or right. So it shouldn't have any horizontal transformations. And then we see that it still crosses that point at 1, 0. It still has that original point from all of your typical logarithmic functions. So it doesn't have any vertical transformations as well. However, we see that it does have a reflection. Looks like it's reflected across the x-axis. It's flipped over and now it's going up. So we see that that it should, because it's reflected across the x-axis, the entire function should have been made negative. So we're looking for no horizontal, no vertical transformations, but the function should be negative, and it looks like it is going to be answer choice G. Let's see, we have another case. This time our vertical asymptote is at x equals 1 as opposed to being at x equals 0. So it has a horizontal shift to the right one. So in our equation, we should see the x being subtracted 1. And then also, let's see, does it have anything else going on? It looks like it doesn't have any reflections. It still crosses its first point 1 unit away from the vertical asymptote. It originally would have crossed at 0 and 1, but we know we said that it moved over to the right one. So now it crosses at 2 and 0. So it only has a horizontal shift to the right 1 unit. So we're looking for one that has x minus 1 in its argument, and that looks like answer choice F. All right, so starting with number 24, we see we have these multi-part problems. So let's go back and forth a little bit. So it says use the given function to answer parts A through F below. First, they give us this logarithmic function, and they ask us to find the domain of it. Remember, we would set this argument greater than 0. We'd have x minus 2 is greater than 0. Adding 2 on both sides, we would end up with x being greater than positive 2 for our domain of part A, meaning that it would go from 2 to infinity. Part B is asking us to graph the function. We have a logarithmic function, and it should be shifted to the right 2 units based on this information here. So we're looking for a graph that's shifted to the right. This one is shifted left. Looks like this one is shifted down. Oh, choice C is the one that shifted to the right, so choice C would be our answer. Then it says from the graph, determine the range and any asymptotes of the function. The range of the function is a logarithmic function. It goes from negative infinity to positive infinity. And the vertical asymptote of the function, we know is shifted to the right 2 units away from being the vertical line x equals 0. So shifted to the right 2 units is going to be x equals 2 for this vertical asymptote here. For part D, now it's asking us to find the inverse of the function. So remember, for your inverse functions, and we have the work over here, the first thing you want to do is use y instead of f of x. So then we have y equals ln of x minus 2. So now we want to swap the x and y coordinates and go ahead and begin solving for y. And as we solve for y, we see we have a logarithmic equation that we can change to an exponential. So we'll have e raised to the x power equals y minus 2. Again, we're solving for y, so now we can add 2 to both sides, and we'll have x e to the x power plus 2 equals y, and that will give us our inverse function, which will be e raised to the x power plus 2. So now we have an exponential function. We have an exponential function that is shifted up 2 units. So part D says find the inverse. We have our inverse. Part E says find the domain and range. The domain of your exponential functions is going from negative infinity to positive infinity. The range of this function now is shifted up 2 units. So it's going from 2 to positive infinity. So we have an exponential function that we're looking to be shifted up 2 units, and we see B is our best answer choice here. Number 25. Number 25 is a similar scenario. We need to start out with the original function, finding the domain, the range, and the rest of the information that goes along with it. So remember, your domain, your argument of your logarithm has to be greater than 0. In this case, it would just be x is greater than 0, so our domain goes from negative infinity to positive infinity. The graph now, we have a logarithmic function, and 6 is being added to it, so that means that is going to be shifted up 6 units. So we're looking for the logarithmic function that's shifted up, that's shifted vertically 6 units. So the answer choice here is going to be A. And then C, it says from the graph, determine the range and any asymptotes of the function. Looking at the graph, the range of the function goes from negative infinity up to positive infinity. The asymptote is going to have a vertical asymptote at x equals 0. Now, part D, where we're looking for our inverse, let's look over here at the work. Again, we swap x and y, we substitute y in for f of x, and then we swap x and y, and we begin solving for y. So we're looking for y. Once again, we go from being a logarithmic equation to an exponential equation. We'll have x minus 6 equals ln y. That means our base is e. So we'll have e raised to the x minus 6 power equals y in this case, and that gives us our inverse function, e raised to the x minus 6. Part E says to find the domain and range of our inverse function here. Find the domain and range. The domain of our inverse function, well, we see we have an exponential function. Once again, our domain of our exponentials is from negative infinity to positive infinity. And our range in this case, it doesn't have any vertical transformations, so it just goes from 0 to infinity. Now looking for our graph based on all of this information, we're looking for an exponential function that is going to be shifted to the right 6 units now. So it's not A, it's not B, it's not C. Looks like D is the one that's shifted over to the right, a significant number of spaces. So we're going to go with answer choice D for this one. Moving down to number 26, another similar problem. They give us another logarithmic equation. First off, we're finding the domain. Remember, we're looking at the argument of the logarithmic expression and setting that greater than 0. So x minus 3 is greater than 0. We end up with x being greater than 3. So that interval is going from 3 to infinity. Now for part B, it says choose the graph of the function below. We're looking for a function that is shifted down 2 units and is going to be shifted to the right 3 units. So shifted down 2 and to the right 3. It looks like answer choice A is the one that we will go with in this case. So we're going to choose answer choice A. Going now to part C, it says from the graph, determine the range and any asymptotes of the function. Let's see, the range of our logarithmic function goes from negative infinity to positive infinity. It looks like it has this vertical asymptote. Now remember, it's shifted over to the right 3 units. So this vertical asymptote is going to be x equals 3. Now for part D, We are looking for the inverse of our function. So we started out with a logarithmic equation. Remember, we take the f of x out, we put y in there for it, and then we would swap x and y. So in this case, now we're going to have x equals -2 plus log base 3 of y minus 3. The x and y's have been swapped. So now we're solving for y. So we need to get the logarithmic expression isolated first. So we'll add 2 to both sides. We have x plus 2 equals log base 3 of y minus 3. So now we are going to change it from logarithmic to exponential. 3 is our base. Over here is our exponent. So we have 3 raised to the x plus 2 power equals our argument now, which is y minus 3. And we are going to finish solving it like a normal equation for y. So we get 3 to the x plus 2 plus 3 now, because we had to add 3 to both sides, equals y. So here is our inverse function. We have 3 raised to the x plus 2 plus 3 now. So that is our inverse for part D. Now we're looking for the domain and range. We see now we have an exponential. Our domain is going to be from -infinity to +infinity. The range of our exponential has been shifted up 3 units. So it's going to go from 3 to +infinity. And when we're over here looking for the matching graph, again, it's going to be shifted to the left 2 units and up 3 units this time. So we're looking for a graph that goes left 3 and up 3. It looks like answer choice B is going to be the one that we're going along with. Now, solving some logarithmic equations. We see all of these say solve the equation and we're typing an integer or a simplified fraction. So I'm just going to blow it up here on the right so that we can see it a little bit clearer. So starting with number 27, it says log base 2 of x equals 5. So the first thing we want to do is change it to exponential form. So we'll have 2 raised to the 5th power. Remember, logs are base. We have base, we have our argument, we have our exponent over here. So we'll take our base, raise it to the exponent, set it equal to our argument, and finish solving. So 2 raised to the 5th power equals x. 2 raised to the 5th power is 32. So x equals 32. 32 will be our answer. Number 28, we have log base 2. Our argument is 8x plus 6, and that equals 6. So the first thing we want to do is change this one to exponential form. We'll have 2 raised to the 6th power equals 8x plus 6. 2 raised to the 6th power, we simplify that as 64. And now we are subtracting 6 from both sides and then dividing by 8. We'll simplify our answer and we are left with 29 over 4 equals x. Number 29, we have log base x of 144 equals 2. So now when we change it to an exponential form, we'll have a quadratic equation in this case. We have x squared equals, or x to the 2nd power equals 144. So now to finish solving this one, we can simply take square roots. So we'll square root the x squared with square root 144, which is going to be plus or minus 12. Now, because of the domain restriction, we do not keep the -12 as a part of our answer. When you get these answers for these logarithmic equations, be careful. Just always go back and just double check with the original equation. Remember, for our log equations, our base has to be greater than 0. So this x has to be greater than 0. So we throw away the -12 part of the solution and we keep the +12. So our answer is only x equals +12 in this case. Number 30 says log base 2 of x, base 2 of 8, equals x. So we're going to change that to exponential. We'll have 2 raised to the x power equals 8. Now we see we have an exponential equation where we want our bases to be the same so we can get rid of them. So we change the 8 and rewrite it as 2 raised to the 3rd power. So then once we do that, we have a common base of 2. We can get rid of our bases and we'll just set x equals to 3. So our final solution is going to be x equals 3.